Well, this will be our last example in the solving systems of linear differential equations section. And it's a little bit different because it's our only example we've done so far that's an initial value or a boundary value problem. So the first equation is x prime plus 5x plus y is 0. And x of 1 is equal to 0. And negative 4x plus y prime plus y equals 0. And y of 1 is equal to 1. So you can see that we go from this to using the differential operator notation. We'll just remember that these are the initial values. But you get a d plus 5 times x plus y equals 0, negative 4x, and then d plus 1 times y, or applied to y, gives you a 0. And that's where we can use the previous theorem, the elimination method theorem. And we're only going to do it for x. We're not going to do it for y for basically because it will look exactly the same as y, for x. Because remember, this is the homogeneous case, and this determinant times x will look the same as this determinant times y. And we don't have to do it because we have some initial values to figure out what our constants should be. So let's proceed. This comes from the theorem. This determinant times x gives you this. So I worked it out. We got d squared plus 6d plus 9 equals 0. I used the characteristic equation since this is a homogeneous equation. And we come up with this. We come with this. This is the first example I think we've had in a long time where we had repeated real roots. Negative 3, I wrote it up there twice. So remember how we get the solution? X of t is c1 e to the negative 3t like usual. But on the next one, we have to do c2t e to the negative 3t. Okay, so I'll go ahead and put a box around that. And if we were to do the same thing with y, we would get y of t equals, I'd have to use different constants, c3 e to the negative 3t plus c4t e to the negative 3t. But we'll find that that's unnecessary if we just go back to equation number 1. Equation number 1, well, before I do that, I know equation number 1 requires x prime. I'm going to go ahead and compute it right now. That's going to be negative 3 c1 e to the negative 3t. Let's see. I want to make sure I get it. Oh, this one's this is pretty easy. It's going to be 2 terms. We got to do the first times derivative of the second plus the second times the derivative of the first. We get negative 3 c2 t e to the negative 3t plus c2 e to the negative 3t. So here's the derivative. That's x prime. So now I'm just going to show equation 1 implies, let's just solve that for y. So we get y equals negative x prime minus 5x. Negative x prime minus 5x. And what does that equal to? Well, negative x prime is the negative of this. So 3 c1 e to the negative 3t plus 3 c2 t e to the negative 3t minus c2 e to the negative 3t minus 5x. Well, here's x. So I'm going to have to say, if I want to multiply, I'm just going to multiply 5 through, so make it negative 15, and positive 5. So let me see if I can line them up. This would be negative 15 c1 e to the negative 3t. Oops, sorry. Easier than that. I was multiplying x prime by 5. We're doing minus 5x. Here's x. So I would have 5 minus 5 c1 e to the negative 3t minus 5 c2t e to the 3t. So we've got 5 terms that if we combine the like terms, we get y equals negative 2c1 plus c2. I combined them and now I grouped them together. E to the negative 3t minus 2c2 t e to the negative 3t. So that's our, I'm going to go ahead and circle it. I'll be consistent. I'll do y of t here. But we still have some solving to do. Notice that we're only using C1 and C2, but we need to actually compute them because we've been given a little bit of extra ammunition. Okay, so x of 1 equals 0. So that implies that x is 0 when t is 1. When t is 1, we get C1 e to the, let me see, x is a 0 when t is a 1, yeah. So we get C1 e to the negative 3 plus C2 times 1 times e to the negative 3. So you could factor the e to the negative 3 out of the right-hand side, and you see that 0 equals C1 plus C2, and that means that C1 is equal to negative C2. So we're getting there. Now we're going to use this initial value to get us exactly what C1 and C2 are. So y of 1 is 1. So y of 1 equals 1 implies that 1 down here is equal to, okay, t is a 1, so negative 2c1 plus c2 e to the negative 3 minus 2c2 e to the negative 3. So I could do a multiplication on both sides to get rid of the e to the negative 3 in both of those terms. I'm going to multiply by e to the third, which would turn those both into 1 and give us an e to the third on the left-hand side. Negative 2c1 plus c2 minus 2c2. Well, that can be simplified. Let me see what's going on here. Negative 2c2, negative 2c1, and then that's a negative c2, so that'd be a minus 3c2. Now let's go ahead and use the fact that c1 is negative c2. That would give us a positive 2c2 minus 3 would be a negative c2. So e cubed is negative c2, implies c2 is negative e to the third. And since c1 is negative c2, c1 is e to the third. So, final answer at the very bottom, we will get C1. Here's X. Okay, this may not be the final answer, but I'm going to try to squeeze it in. Actually, nope, I don't have a blank board down there. So, X of t is negative 3c1 C1 is e cubed, e to the negative 3t minus, looking at this one now, C1. Let me start that over. I was looking at this one again. Okay, x of t is C1, which is e cubed, e to the negative 3t, plus C2, which is e cubed, or negative e cubed, t, e to the negative 3t, y of t, and I'll simplify that in a minute. Okay, what do we got here? We're going to have a negative 2c1 is 2e cubed minus an e cubed would just be an e cubed, so negative e cubed, because that was 2c1. Let me make sure I got that right. 2c1 is e cubed, plus that would be 2c cubed minus e cubed is just e cubed, so negative e cubed, e to the negative 3t, minus 2, c2 is negative, so that becomes a positive e cubed, t, e to the negative 3t. So now we've got the simplification here, where we've got e to the 3 times e to the negative 3 to the t. Let's see, that I guess I'll just combine it into adding exponents. So final answer, let me erase something over here. X of t is equal to e raised to the negative 3t plus 3 negative 3t plus 3 minus t e to the negative 3t plus 3, and y of t is e, or I should say negative e to the negative 3t plus 3 plus 2t e to the negative 3t plus 3. Final answer, I'm going to double check that. The first one is positive negative, positive plus 2. Yep, looks great.